This is the last lecture in the course Basics of Mechanical Engineering 2. I am Dr. Amandeep Singh Oberoi from IIT Kanpur. We are going to talk about metrics for sustainable manufacturing in this lecture. I will walk you through the following contents: steps for selecting sustainability metrics. Then we will talk about three kinds of the metrics that we talked about in the triple bottom line. We talked about the economic, we talked about the social, we talked about the environmental impacts. And for economic, I'll talk about financial metrics, that is net present value and cost of ownership, which is also called as life cycle costing. In social metrics, we'll give a brief introduction to the literacy rate calculation, healthcare assess calculation, HDI, Human Development Index calculation. Then environmental metrics, we will talk about carbon footprint calculation, waterproof footprint calculation, and air quality index calculation. Then some problems and solutions. I will not take all of the metrics, but few of them I will only discuss. First is steps for selecting sustainability metrics. First, select or set the goal and scope. Similarly, we have to define the overall sustainability objectives, establish criteria for selecting relevant metrics, then align goals with environmental, economic, or social aspects, what we are going to study. Identify the issues that is under study, that is determine the general sustainability concerns related to the product, process, or system. Categorize issues into the environmental, economic, and social domains. Consider regulatory requirements and stakeholder expectations. Then we break down the issues. Break down the issues means, like we saw a complete production system to the production line to the unit manufacturing process, we have to identify sub issues contributing to each major sustainability concern, analyze the factors such as resource consumption, emissions, life cycle costs, social impacts, etc. When we break it down, we can even use this kind of the metrics here. You can see the four quadrants are here, and we have manufacturing phase consumption or impact could be low or high here in the x-axis. In the y-axis, we have use phase consumption or impact low or high. If manufacturing and use case both are low, then it is most sustainable. If both are high, it is least sustainable. In between, we have to pick between the use phase consumption or manufacturing phase consumption. If use phase consumption is high and manufacturing phase is low, that is, we have to increase the product efficiency, design, or manufacturing leveraging. And in case manufacturing phase consumption is high and use phase consumption is low, we have to increase process efficiencies, that is, we have to focus upon manufacturing. That is, we break down the issue. Then comes defining the criteria, establish criteria to evaluate and prioritize sustainability metrics. That is, how do we collect the data? Are we going to take unit manufacturing data or unit process data, or we're going to take aggregate data of the factory? Consider factors like relevance, measurability, comparability, impact significance, etc. Then we have to choose the metrics. Select quantitative and qualitative indicators based on the defined criteria. Quantitative means we have selected or we have quantified or we have taken specific quantified data. For example, carbon footprint is a quantified data. For example, energy consumption is a quantified data. Now, quality data, for example, pollution, yes or no, treatment, yes or no, then beyond specific limits, pollution going or not, yes or no. This yes or no is kind of a qualitative data. We choose the metrics accordingly. Ensure the chosen metrics effectively measure sustainability performance. Validate metrics through stakeholder input and industry benchmarks. Let me now try to see certain metrics. Financial metrics for manufacturers. First financial metrics is net present value. Net present value is the discounted value of any assets that we have to the present time for the next coming years. So we have to subtract the investment, that is minus I naught. I naught is the initial investment, and the further cash flow period in time t, xt, is discounted by an interest rate of I. So it becomes minus I naught plus summation of xt by 1 plus I the part t, and this summation is from the time 1 to the t. This is capital T, the time till which this is being discounted. I will just do one problem statements in the end of this lecture as well. So net present value, if it is more than 0, investment is expected to generate more value than its cost, so it is financially viable. If it is equal to 0, it is just a break even. Whatever we invest would only come back, no profit. If it is less than 0, investment would lead to loss. So net present value is one of the financial metrics. Another financial metrics that I talked about is cost of ownership. This is also known as the life cycle costing. Now let me take an example. For example, you purchase any equipment. If I suppose purchase a bike, motorbike I am talking about, initial investment is suppose rupees 50,000, and each month suppose you are spending rupees 1,000 on the petrol, that is the operational cost. This is the operational cost C3, initial cost 50,000 is C1, and setup cost is C2. For equipment, for the lathe machine, for any setup machine, there is a setup cost as well. For example, for bike, you try to develop a shed, and to develop a shed, you are investing rupees 10,000. And each month you are spending rupees 1,000 on petrol, and in 1 year this turns to be rupees 12,000. And if you are operating this bike for 5 years, the total investment would be 50,000 plus 10,000 plus for 5 years 12 into 5, 60,000. This is the total cost of ownership of the product throughout its life cycle. It is the cost of ownership. So this turns out to be rupees 1,20,000 for a 5-year period. So here cost of ownership is given by a relation C1 plus C2 plus C3, that is discounted, that is C3 present value we are talking about. Present value C3 by 1 plus I par T, this is the present value, into N. N is the number of pieces of equipment, and this is divided by B into VE, where B is total amount of output from the system and VE is the economic value of unit output. Then comes next matrix, that is social sustainability matrix. Social sustainability ensures that societies provide equitable access to essential resources, services, opportunities while promoting well-being and quality of life. It includes various metrics that measures literacy, healthcare access and overall human development. Below are key calculations and explanations for fundamental social sustainability indicators. First is literacy rate calculation. That is the number of people who can read and write, who are educated to some extent in the given society that is under study. Literacy rate is a key indicator of educational development, representing the percentage of people within a population who can read and write. High literacy rates contribute to better job opportunities, economic growth, improved living standards. To calculate this, we have a simple relation here. Literacy rate is literate people per unit total population into 100. Now, not only literacy, people should be healthy as well. Then comes second indicator, which talks about healthcare access calculation. Healthcare access measures the availability of essential medical services, including hospitals, clinics, life-saving medicines. Ensuring widespread healthcare access reduces mortality rate, improves public health and increases life expectancy. So healthcare access percentage is people with access per unit total population into 100. Then comes Human Development Index calculation. The HDI, Human Development Index, is a composite measure used by United Nations Development Programme to assess a country's overall development. HDI considers 3 major factors. There is a Nobel laureate from India, Amartya Sen, who has also worked in this direction to develop the HDI. So life expectancy index is LEI, that measures health and longevity based on average life expectancy. Then we have education index that evaluates the educational attainment, including school enrollment. Then we have income index, that assesses the standard of living based on per capita income. A higher HDI value closer to 1.0 indicates a better quality of life, whereas a lower HDI value suggests poor living conditions and development challenges, because those 3 pointers are there: life expectancy index, education index and income index. We divide it by 3, take the total average. This is known as Human Development Index. Then comes the environmental sustainability matrix. Environmental sustainability focuses on preserving natural resources, reducing pollution and minimizing human impact on ecosystems. Key indicators include carbon footprint, water footprint, air quality index, and renewable energy share. These metrics help measure and track environmental performance, enabling policymakers, industries, and individuals to adopt sustainable practices. So carbon footprint calculation is very important here. This represents a total amount of greenhouse gases, particularly carbon dioxide, released into the atmosphere due to human activities. It is measured in kgs or tons of carbon dioxide equivalent. Carbon emissions result from activities such as electricity usage, transportation, industrial processes, and food production. As I said, carbon dioxide equivalent for different countries for the kinds of electricity generation source could be different. For the nuclear power, it is more clean. Then comes hydropower. Then comes other stations. For example, from the thermal power, it is very high because the energy that is used and coal is being burnt, the carbon dioxide emission is very high. Major sources of carbon footprint are electricity consumption, that is coal, gas, oil-based power generation; transportation, its emissions from fuel consumption in vehicles, airplanes, and ships; industry, that is manufacturing processes, cement production, steel production. Deforestation is also the contributor to the carbon footprint, that is reduced carbon sequestration due to tree loss, and when carbon sequestration is increased, you get carbon credits. So I'm only talk about very simple metrics here because we are talking about very basics of mechanical engineering and basics of sustainability engineering here. So total carbon dioxide emissions is equal to energy used in kilowatt hour into the emission factor, that is kilograms of carbon dioxide per unit kilowatt hour. So ways to reduce carbon footprint are using renewable sources of energy, solar, wind, geothermal, etc. Reducing electricity consumption, that is we might use LED bulbs which have lesser consumption. Energy efficient appliances, for example energy efficient motors, or maybe high star rating appliances. Promoting public transport and electric vehicles, for instance using a bus that could transport 30 people in a go than using 30 cars separately. Planting trees and afforestation programs. So not only carbon footprint, we also have water footprint and air quality. Water footprint calculation. Water footprint is the total fresh water used by individuals, industries, or countries measured in cubic meters to track and manage water consumption. Categories of water footprint, if I try to talk about, blue water, green water, and grey water are three categories. Total water footprint is equal to blue water, green water, and grey water all together. What is blue water? Fresh water from lakes, rivers, groundwater. Green water is rainwater stored in soil and used by plants. Grey water is water required to dilute pollutants to maintain water quality standards. Ways to reduce water footprint are rainwater harvesting, groundwater recharge, collect rainwater or recharge aquifers, efficient water uses, and wastewater management, that is using water efficient appliances and reuse wastewater. There are multiple water footprint systems nowadays. Groundwater extraction and managing the wastage of groundwater is very important. There are certain AI tools nowadays being developed. If I say AI, generally these are industry 4.0 or IoT tools that measure that each pump, if it is pumping water to different stations, from that pump to finally what is the output coming in between. If leakage is there, the sensor attached here and at the end point that could detect that in between there is some leakage that has happened. Then comes air quality index. AQI or air quality index is a standardized measure of air pollution levels indicating how clean or polluted the air is. For example, at certain specific points in the city of Kanpur, AQI is around or more than 300. I have given the table here. At certain points when I went to Brampton in Canada, the AQI was only 4. It depends upon the quality of air we have. So it is calculated based on major pollutants such as particulate matter, PM. We have PM levels, PM10, PM2.5 or so, nitrogen dioxide, then carbon monoxide, sulfur dioxide, and ozone. High AQI values indicate poor quality of air and potential health risks. So there are AQI values. Air quality very good is between 0 and 50. There is no risk of health effect. Between 51 to 100 is moderate, that is acceptable, but can affect sensitive groups. Sensitive groups means people who are prone to breathing problems or so. Then between 101 and 150, unhealthy or sensitive groups, risk for children and elderly. 151 to 200, unhealthy, health warnings issued. 201 to 300, very unhealthy, serious health effects. 301 plus hazardous, that is emergency conditions are there. So in the industrial areas, close to chimneys or close to industrial areas, sometimes it is really 301 plus. AQI is calculated using this relationship, that is the difference between the pollutant concentration and minimum concentration is taken over by the maximum concentration and the minimum concentration difference, and this is converted into percentage, that is multiplied by 100. Ways to improve air quality are promoting electric vehicles and public transport, reducing industrial emissions through cleaner technologies, increasing urban green spaces, that is parks, trees, plantations, banning open burning or waste agriculture residue. Next comes renewable energy share calculation. Renewable energy share is the percentage of total energy consumption derived from renewable sources such as solar, wind, hydro, geothermal, biomass, etc. Increasing renewable energy use helps reduce dependence on fossil fuels and lower carbon emissions. Major renewable sources that I have just talked about: solar, wind, hydropower, biomass and geothermal are there. How do we calculate? Renewable energy share is taken over the total energy use multiplied by 100, we get the percentage of renewable energy share here. Benefits: it reduces greenhouse gas emissions, air pollution, increases energy security and reduces fossil fuel dependence, generates employments in green energy sector, helps mitigate climate change impacts, but it has initial investment that is there and availability. For example, solar power station could be set in India, but it cannot be set in places where sun is not there. It cannot be set in places like Kashmir. So then come maintenance and end of life planning. For example, the PV cells used in solar power stations have a life. They have life between 8 to 20 years, depending upon the quality that you are using. So end of life planning, how do we dispose it of, that is also very important. So these are some of the concerns which are there. So these are very basic metrics that I have introduced you to, though this course is for the basics of mechanical engineering. But when we talk about sustainability in manufacturing, these all metrics are taken care of. Now I will take a few problem statements and I will close this lecture. The first problem here talks about net present value, NPV. A company is considering an investment that requires an initial outlay of rupees 50,000. The project is expected to generate the following cash flows over the next 4 years. Year 1, rupees 15,000, year 2, rupees 20,000, year 3, rupees 25,000, year 4, rupees 10,000. The company's discounted rate is 10%. Calculate the NPV of the investment based on your calculations. Determine whether the company should proceed. That is, we have to check whether NPV is positive or not. If it is positive, we will accept it. Let me try to find the solution. Here initial investment is 50,000 and per year we have these cash flows. So initial investment is I naught, that is rupees 50,000, and year 1, year 2, year 3, year 4 rates or the cash flows are given, which are 15,000, 20,000, 25,000 and 10,000 rupees respectively. I have a discounted rate I is equal to 10%, that is 10 by 100, this is equal to 0.1. So year 1, if I try to calculate, year 1 cash flow would be 15,000 by 1 plus 0.1 per t. Time is the first year 1. This would be rupees 13,636.36. For year 2, this is the cash flow 20,000 per unit. We have discount rate 10%, 1.01, and for the second year. So this is rupees 16,529. Similarly, we will calculate for year 3 and year 4. where we have 1 plus 0.1 par 3 in the denominator, and we have 25,000 in the numerator. And for year 4 we have rupees 10,000 in the numerator, and for the 4th year it is 1 plus 0.1 par 4. So these values are rupees 8782.87 for year 3 and rupees 6830.134 for year 4. So total cash flow is the sum of these. Total present value of cash flow is present value for year 1 plus present value for year 2 plus present value of year 3 plus present value of year 4. If I add all of these, this turns out to be total of rupees 55,778.36. And total present value, now net present value, could be calculated as this value, that is total present value minus initial investment, which is 55,778.36 minus 50,000. This is equal to rupees 5778.36, which is greater than 0. Hence, we give a decision yes, we should go for the investment. Another problem statement talks about the carbon footprint, the sustainability metric. A forklift truck transfer material from one machine group to the other in a factory. There are machine groups in a factory. There could be lathe group, there could be milling group. This is a kind of a process layout. There could be grinding group, etc. For one group to another, a forklift truck transfers the material, and this is the data given. We have to calculate the total carbon footprint. In material handling system, the total distance traveled by truck is 60 kilometers daily. Truck fuel efficiency is 15 kilometers per liter. Carbon emission factor for the diesel fuel is 2.65 kilograms of carbon dioxide equivalent per liter. So for different fuels, there are different emission factors, and we have been given equipment operation. Daily electricity usage is 4 kilowatt hours per machine. Number of machines are 15. Carbon emission factor for electricity is 0.8 kilograms of carbon dioxide equivalent per kilowatt hour. For different fuel, for different electricity generation sources, the factors are different. For example, it is given for diesel, it is 2.65. Had it been petrol, this factor is around 2.5 kilograms of carbon dioxide per liter. And for maybe LPG, this factor is different, that is around 1.6. That is a cleaner fuel. Also, depending upon the kind of the electricity generation source, for coal based electricity, that is for thermal power plant, this is 0.8 kilogram. This is coal based plant. And if it is natural gas based plant, this factor would be around 0.4 kilograms of carbon dioxide per kilowatt hour. And for renewable sources of energy, this factor is very less. It could be of the order of 0.05. This is for renewable sources. Now, I need to calculate material handling and equipment operation carbon footprint separately. So, carbon footprint total would be carbon footprint for material handling plus carbon footprint for equipment operation. For calculating carbon footprint in material handling, we have to see the given data. Carbon footprint for material handling, this is equal to the liters of fuel used. We have been given here, there is a truck with an efficiency of 15 kilometers per liter and total travel is 60 kilometers daily. So that means 60 kilometers daily by 15, we have 4 liters. So we have 4 liters of fuel. This times the carbon emission factor, that is 2.65 kg of carbon dioxide equivalent per liter. If I try to multiply it, this turns out to be 10.6 kilograms of carbon dioxide equivalent. And carbon footprint for equipment operation, this is equal to energy used into carbon emission factor. Energy used is 4 kilowatt hours per machine into number of machines. Total energy use is this, into the emission factor is 0.8. This turns out to be 48 kg of carbon dioxide emission. So total carbon footprint is now carbon footprint total is sum of the carbon footprint from material handling, that is 10.6, and the carbon footprint from equipment operation, that is 48. This is 58.6 kilograms of carbon dioxide equivalent. With this, I am closing this lecture and this course on basics of mechanical engineering 2. We talked about the manufacturing processes. We started with the materials, different kinds of the materials and materials treatment systems. Then we talked about basics of casting, the processes of casting, the materials in casting, the various problem statements were also discussed there. Then we talked about forming. Then we went to the machining, and we talked about non-conventional machining processes. Welding was also talked in between, and I have talked about sustainable manufacturing systems in the last week here. This is the basics of mechanical engineering second delivery that we have given. The third delivery would also go basics of mechanical engineering 3, that will talk about the fluid mechanics and thermal science. Let us meet in the next course. Thank you.